Okay, dear students, until we have studied expansion of determinant, how to find the value of determinant of order 2 and order 3. Also, we have studied applications of the determinant to solve the simultaneous equation, that is the Cramer's rule, to check the consistency, to find the area of triangle, to check whether the points are collinear or not, and to find the area of quadrilateral. Now today we'll study these minors and cofactors of the determinant. So suppose we'll consider D is equal to determinant A1 B1 C1, A2 B2 C2, A3 B3 C3. Now here minor of element, in general we write Aij. So Aij means element of ith row and jth column is equal to determinant obtained by eliminating ith row and jth column of element Aij. So when we will find the minor of element Aij, will eliminate ith row and jth column of Aij. So suppose when we will find minor of A1, we eliminate row and column of that element, and the determinant of remaining elements is the minor. So for example, minor of A1 is equal to determinant B2 C2 B3 C3. Minor of, suppose B2 you want to calculate. Now B2 is the element of second row, second column. So we will eliminate second row and second column. So eliminate the determinant of remaining elements. So A1 C1, A3 C3, the minor of the B2. Similarly, suppose if you find the minor of C3, so that is equal to, now C3 is the element of third row and third column. So we eliminate third row and third column. The determinant of these remaining elements, that is the minor of C3. So A1 B1, A2 B2. So this is the minor of C3. So this is the concept of the minor of elements. Now here we find out the cofactor. So cofactor of, in general we consider Aij. So Aij the element. So minor we can indicate Mij. So this is the Mij. So cofactor of Aij, we can indicate this as a Cij or maybe Aij. So that is equal to minus 1 raised to I plus j into Mij. So already we have studied how we find the minor of ijth element. That is, we are obtaining the determinant by eliminating row and column of that element Aij, that is, we are eliminating ith row and jth column, and the determinant of remaining elements is the same sequence, that is the minor. Cofactor of Aij is equal to, we are giving the sign, minus 1 raised to I plus j into Mij. So for example, cofactor of A1 equal to, or we can write A11 element. A11 means element of first row and first column. So that is equal to C11 will say. So that is equal to minus 1 raised to 1 plus 1 into M11. So M11, we know this is the M11. This is M22. This is M33 and so on. So that is equal to minus 1 raised to 2, that is the plus, so M11. So positive sign is coming. Suppose cofactor of B1 you want to calculate, suppose. So B1, or that is equal to C1 2, first row second column, minus 1 raised to 1 plus 2 into M12. Now minus 1 raised to 3 is minus, so minus M12. Now M12 is equal to determinant. So eliminate first row and second column, A2 C2, A3 C3, A2 C2, A3 C3, A2 C2, A3 C3. So this is the method to find minors and cofactors of the determinant. Now this, what is the use of these cofactors and the minors? So very much useful is the determinant. So value of the determinant is the sum of the products of elements of any one row or any one column. So value of determinant is equal to sum of products of elements of any one row or column and their cofactors. Now you know this, initially when we are evaluated the value of the determinant of order to order 3, we are expanded determinants in terms of elements of first row. So in regularly we are eliminating the value, we are finding the value of determinant by expanding determinant in terms of the elements of first row. Regularly we are expanding determinant in terms of first row, but determinant can be expanded in terms of any one row or column, but it must be stated. So when we are expanding determinant in terms of elements of first row, we are not writing, we are expanding the determinant in terms of first row. But when we expand the determinant in terms of elements of any other column, suppose C1 or C2 or C3 or R2, R3, etc. So we are writing expanding in terms of the C2, expanding in terms of R2 and so on like this. Suppose, for example, D is equal to, we consider determinant 90, 102, 111, 0, 5, 6, 0, 3, minus 1. Now you want to expand this determinant, you want to find the value of this D, find the value of D is equal to. So D is equal, now here if we expand this determinant in terms of the first row, our regular method, so that is the time consuming. You want to take this element into its cofactor, then this element into its cofactor, this element into its cofactor, and you want to do the summation of that products, and then we get the value. But here, as two elements in the first column are 0, if we expand in terms of the first column, only one cofactor you want to consider. So we will expand to reduce the time. Expand determinant in terms of C1. So we will expand in terms of the first column. So D is equal to, when we will expand this, so first element 90 into its cofactor, so minus 1 raised to, now here one thing here, this will understand again. So if 2 by 2 determinants, so signs of cofactors, signs of cofactors. So when we understood the signs of cofactors, so if we consider the determinant of order 2, so here first element minus 1 raised to 1 plus 1, 2. So plus sign is coming, minus 1 raised to 1 plus 2. So minus is coming, minus and plus. So for 2 by 2 determinants, signs of the cofactors are plus, minus, minus, plus are coming. And D is equal to, suppose 3 by 3 determinant is there. So minus 1 raised to 1 plus 1 is plus sign coming. Then minus, then minus 1 raised to 1 plus 3, 4, even power, plus, minus, plus, alternatingly we are getting the signs. So like this we will get the signs of the cofactors, what? Determinant of order 2 and determinant of order 3. So here we get positive sign. So D is equal to, we get 90 into positive sign. So my determinant 5, 6, 3 minus 1. This is the minor of that. Plus, now this 0, so not essential to write. Then also we write, so 0 into its sign is here minus, 0 into 1, 0, 2, 1, 1, 1 and 3 minus 1 plus 0, the plus minus plus signs. So 0 into 1, 0, 2, 1, 1, 1, 5, 6. So this actually in practice not essential to write. You drop the steps. This is only the solution. So for your understanding of the cofactors, I have written. So this is equal to 90. Now solve this determinant of order 2. 5 into minus 1 is a minus 5, minus 18. So that is equal to 90 into minus 23. So that is equal to So D is equal to, we get value minus 2070. So in this way, but here you want to indicate this, we are expanding in terms of C1. So in this way, we can expand the determinant in terms of C2 or C3, maybe in terms of R2, R3, etc. and so on. So this is about the minors and cofactors and how these are applicable, used in the determinants. Actually, these minors and cofactors are very much useful in the chapter matrices, that is to find the adjoint of the matrix and its inverse by the adjoint method.